The world around us, from the tallest mountains to the flattest plains, wasn't always this way. It's in a constant state of change, being shaped and reshaped every single day. So today, we're going to explore the incredible natural forces, the agents of change, that sculpt our planet and create the amazing landscapes we see. Let's get started. So, what are these forces, really? You see, the Earth's surface isn't static at all. It's actually a dynamic battleground between forces pushing land up and forces wearing it down. And if we can understand the key players in this geological game, we can really start to understand the story of our physical world.
Okay, to get on the same page, we need a couple of key terms. First, any physical feature on the Earth's surface, big or small, is a landform, and the forces that create them are the geomorphic agents. Just think of them as nature's sculptors. They use two main tools: erosion, which is the process of carving away the land, and deposition, which is the process of building it back up by dropping sediment.
So here's our game plan for this explainer. We're going to start with the most common force, running water. Then we'll take a trip underground to see what groundwater does. After that, we'll look at the immense power of glaciers, and we'll finish up at the coast with the energy of waves. And finally, we'll tie it all together to help you nail these concepts for your exams.
First up, running water. You could argue this is the most important geomorphic agent on the planet. I mean, especially in humid places that get a lot of rain, like most of India, its work is everywhere, creating what we call fluvial landforms. You know, you can think of a river as having a life cycle. In its youth, it's full of energy, rushing down steep slopes, cutting straight down and carving out sharp V-shaped valleys. Then, as it enters its mature stage, its energy shifts. It starts eroding side to side, making its valley wider. And finally, in its old age, the river gets slow and lazy. Its main job becomes deposition, dropping sediment. Over a very, very long time, this can wear the landscape down to an almost flat plain called a peneplain. So really, a river's work breaks down into two main jobs. You have erosional features like canyons and valleys, which are formed when the river has a lot of energy and is cutting into the land. And then you have depositional features like deltas and floodplains, which get built up when the river slows down and drops all the material it's carrying. So the big takeaway here is that a river is both a destroyer and a creator, constantly reshaping our world. Let's look at two incredible examples of erosion. On the left, you see a gorge. Notice those super steep, almost vertical walls? That happens when a river cuts through hard, resistant rock. A great example is the gorge on the Kaveri River. Now on the right is a canyon. See how the sides are more like steps? That's a classic sign that the river has carved through layers of softer sedimentary rock. It's the geology of the area that decides what the final shape will be.
Now this is a really fascinating process. We're looking at a meander, which is just a big bend in a river. What's happening here is simple physics. The water on the outside of the curve moves faster, so it erodes the bank. The water on the inside is slower, so it deposits sediment. Well, over time, that bend gets bigger and bigger until the river decides to take a shortcut and cut straight across. That old loop gets left behind, and eventually it becomes a beautiful crescent-shaped oxbow lake. Okay, now let's look at what happens when a river drops its load. On the left is an alluvial fan. This happens on land. Imagine a stream coming out of the mountains. It suddenly hits flat ground, loses all its speed, and just dumps all the heavy, coarse stuff it's carrying in a fan shape. A delta, on the other hand, forms in water. When a river flows into a calm sea or a lake, its speed hits zero, and it deposits all the fine sediment it was carrying, building new land. The Krishna River Delta is a perfect example of this right here in India. All right, we've seen what happens on the surface, but what about underneath our feet? Our next agent is groundwater, and it creates a truly unique and almost alien-looking landscape by dissolving rock. This is called karst topography, and you find it in places with a lot of limestone.
So in a karst landscape, it all starts at the surface. Rainwater becomes slightly acidic and dissolves the limestone, forming pits called sinkholes. That water then trickles deep underground, carving out huge networks of caves. But inside these caves, something incredible happens. As water drips from the ceiling, it leaves behind tiny mineral deposits. Over thousands of years, these build up to form stalactites that hang down, and their partners, stalagmites, that grow up from the cave floor.
Okay, so we've gone from the chemical work of water to the brute force of ice. Now we're talking about glaciers. These massive, slow-moving rivers of ice are absolute powerhouses of erosion and deposition. They're responsible for some of the most dramatic mountain scenery on Earth, including the Himalayas.
Now here's a crucial difference you absolutely have to know, especially for exams: the shape of a valley. A river cuts downward, creating that classic V shape, but a glacier is different. It's like a giant sheet of sandpaper that scours the entire valley, bottom and sides, creating a wide, unmistakable U-shaped valley. And when those deep glacial valleys later get flooded by the ocean, you get those stunning landscapes called fjords.
Glacial erosion creates really sharp, dramatic features. At the very top of a glacial valley, the ice carves out a huge, bowl-shaped basin. That's called a cirque. Now imagine you have several cirques eating away at a mountain from different sides. They can carve it into a sharp, pyramid-like peak called a horn. In fact, Mount Everest is a prime example of a horn. And that razor-thin, jagged ridge you see between two glacial valleys, that's an arête.
So what happens when all that ice melts? Well, it leaves behind everything it was carrying. This big, messy pile of unsorted rock and dirt is called glacial till. Often, this till gets pushed into long ridges called moraines, which basically mark where the glacier used to be. You also get eskers, which are these long, winding ridges left by streams that float in tunnels under the ice. And then there are drumlins, smooth, oval hills that act like geological weather vanes, telling us which direction the ice was moving.
All right, for a final stop, we're heading to the coast. This is where the relentless energy of ocean waves is constantly reshaping the boundary between the land and the sea. It's one of the most dynamic environments on the planet. And you don't have to look far for a perfect example of this. Just look at India's own coastlines. They're completely different. The west coast is generally high and rocky. It's an erosional coast, full of features like steep sea cliffs. Now contrast that with the east coast. It's low-lying and sedimentary. It's a depositional coast, famous for its massive deltas, wide beaches, and lagoons.
So let's quickly identify some of these coastal features. The constant pounding of waves carves out steep sea cliffs. Sometimes they'll dig out a sea cave at the base. If the headland gets eroded all the way through, you might be left with a lonely pillar of rock called a sea stack. On the depositional side, currents can build long, narrow ridges of sand called spits that stretch out into the water. And if a spit grows long enough to enclose a body of water, it creates a calm lagoon behind it.
Okay, let's pull all of this together. For any exam, the absolute key is to be able to connect the right landform to the right geomorphic agent. If you can do that, you're well on your way.
Let's do a super quick recap. When you hear running water, you should immediately think of things like V-shaped valleys and deltas. For groundwater, it's all about that underground world, caves and stalactites. For glaciers, the big ones are U-shaped valleys and moraines. And finally, for waves, think of sea cliffs and spits. Getting these associations down is absolutely crucial.
All right, let's put that knowledge to the test with a prelim-style practice question.
Okay, let's work through this. Option A, a cirque, is from glacial erosion, so that's out. B, a stalactite, is from groundwater. Nope. D, an oxbow lake, is from a river, so that leaves C, a drumlin, which is a hill made of glacial till, a classic depositional feature. The correct answer is C.
Now let's try a question that requires a bit more analysis, something you might see in the mains.
For a mains question like this, you can't just list features. You have to actively compare and contrast. A great answer would start with the most obvious difference, the V-shaped valleys of rivers versus the U-shaped valleys of glaciers. Then you could talk about the overall landscape, how water creates more rounded features while ice carves out sharp, angular ones. And of course, using specific examples for each point is what will really make your answer stand out. And that brings us to the end of our journey through the forces that shape our world.